Hello student, we are from Devi Mahalakshmi Polytechnic Titwada, Department of Computer Engineering and Information Technology. Semester 5th, subject Operating System. Presented by Ms. Anita Sharture. Chapter number 4, Schedulings and CPU Scheduling and Algorithms. In previous lecture, we have discussed about the scheduling. Learning outcome of this video: to understand about the scheduling algorithms. CPU scheduling deals with the problems of deciding which of the process in the ready queue is to be allocated the CPU. The algorithms used by the scheduler to carry out the selections of a process for executions is known as scheduling algorithm. A process or CPU scheduler schedules different processes to be assigned to the CPU based on particular scheduling algorithms. Scheduler algorithms are either non-preemptive or preemptive. The different CPU scheduling algorithms are first come first serve scheduling algorithms, shortest job scheduling algorithms, priority scheduling algorithm, round robin scheduling algorithm. In this video we will learn about the first come first serve, FCFS and SJF shortest job algorithms. In computing, scheduling is the method by which work is assigned to resources that complete the work. The work may be virtual computations elements such as threads, processes or data flows, which are in turn scheduled onto the hardware resources such as processor, network links or the first come first serve algorithm, FCFS scheduling algorithms. It is the similar type of algorithms in which the process that requests the CPU first is allocated the CPU first. In FCFS scheduling algorithms, processes are scheduled in the order they are received. The FCFS algorithms is easily implemented by using a queue data structure for the ready queue. Jobs are proceed in the order of their arrivals in the ready queue. It can be implemented with FIFO. FIFO, that means first in first out queue. In FCFS scheduling algorithm is non-preemptive algorithms. Once the CPU has been allocated to a process, that process keeps the CPU until it wants to release the CPU, either by terminating or by requesting input-output. In time-sharing system, it is not useful because process will hold the CPU until it finishes or changes a state to wait state. The first come first serve is the simplest scheduling algorithm. The process that requests the CPU first is allocated the CPU first. The implementations of the FCFS policy is easily managed with a FIFO queue. When a process enters the ready queue, its PCB is linked onto the tail of the queue. When the CPU is free, it is allocated to the process at the head of the queue. The running process is then removed from figure shows the number of processes are waiting in a process queue, and whenever first is come in the queue, that times its first is executed. So jobs are executed on first queue, first come first serve basis, and it is on non-preemptive preemptive scheduling algorithms. Easy to understand and implement. Here, 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6 is the waiting for the processes, and first is going for the execution. So, here the first come first serve is there. The first come and first serve. Whenever you get given the first process, this process is this process is going for execution in the first stage, and after another second stage is after execution of the first stage, second is going to the next for the execution. Okay, then the first is executions and second is for the waiting. After that, second is going for execution and third is the waiting stage. Like this, the first come first serve is there. Example of this first come first serve basis. Then here the number of process is for is it is the waiting for the execution. So process 4s are waiting for execution, P0, P1, P2, P3, and then arrival time is given for the execution time. And in this example, the process, how many processes are there? How many arrival timings and how many time for execution? So there are the this is the given in a table, and after execution, after solving the first come first serve, how many times required for this execution, then the P0, P1, P2, P3. Then firstly, then our giant chart is a horizontal bar. The chart developed as a productions control tools in 1917 by Henry, an American engineer, and it is the this is a social scientist. So the P0 is going for the execution. That time the 0 times is considered. After that, execution time is given 5. So P0 is taking the time. P0 is taking the time for execution is 5 minutes. So 0 5 0 to 5. After that, the first come first serve is there. That's why the P1 is entered for the execution. Whenever completions of the P0, after that P1 is given for the execution. Then 5 to 3. So that means 3 is adding for in 5. So 5 plus 3 is the 8. So 8 second is given for execution in P1. After that, 8 plus 8 is the 16 for P2, and P3 is the 16 plus 6 plus 22 is given there. Got it? Then wait time of each process are as follow. So arrival time is also given there. So that's why the arrival timings is divided. So, and after that, second another example of the process P1, P2, P3. There are the 3 processes are given for execution, and burst time is the 24:33. 24 is given for P1 is given for 24, P2 is 3, and P3 is equal to 3. Then you had to write, you had to draw the Gantt chart. So in the first enter below the process P1. P1 is the 0 execution starting time is the 0. After that 24 time is the execution time 24. After that 24 plus 3 is the P2, and P2 is the 27th time. Execution P2 wants to execute the process 27 times are given there, and P3 wants 30 seconds for executions. 27 plus 3 are 30. Then in the second chart below, the same 3 processes have an average waiting times are there. 0 plus 3 plus 6 is equal divided by 3. 3 is given for the how many number of processes are there? There are the three processes are there. So 3 is equal to 3.0 ms, and after that this reductions is substantial. The P2, P3 and P1 is there. So P2 is P2's next is FCFS can also block the system in a busy dynamic systems in another way known as the convo effect. When one CPU intensive process blocks the CPU, a number of input-output intensive processes can get backed up behind it, leaving the input-output devices idle. When the CPU hop finally relinquish the CPU, then the input-output processes pass through the CPU quickly, leaving the CPU idle while everyone queues up for input-output, and then the cycle repeats itself when the CPU intensive process gets back to the ready queue. The FCFS algorithms is non-preemptive. Once the CPU has been allocated to a process, that process keeps the CPU until it releases the CPU, either by terminating or by requesting IO. The FCFS algorithms is thus particularly troublesome for time sharing system, where it is important that each user get a share of the CPU at a regular intervals. Advantages of a FCFS. The FCFS is easier to understand and implement as processes are simply to be added at the end and removed from the front of queue. No processes from in between the queue is required to be accessed. FCFS is well suited for batch systems where the longer time periods for each processes are often acceptable. The shortest job first algorithms. The SGF scheduling algorithms is also known as shortest process next SPN scheduling algorithms or shortest request next SRN scheduling algorithm that schedules the processes according to the length of the CPU burst they require. In SGF's algorithm, the process with the shortest expected processing time is assigned to CPU. Hence, the name is shortest job first. Job or processes are processed in this ascending order of their CPU burst times. Every time the job with a smaller CPU burst time is selected from the ready queue. If the two processes having same CPU burst times, then they will be scheduled according to FCFS algorithms. The performance of their algorithms is very good in comparison to FCFS. The SJF scheduling algorithm is probably optimal. It gives the minimal average waiting time for a given set of processes. By moving short process before a long one, the waiting time of a short process decreases. The concurrently average waiting time reduces. In SJF scheduling algorithm, the process in the ready queue with the shortest expected the processing time is assigned to CPU next. The SJF can be evaluated in two different manners. Non-preemptive SJF. In this method, if CPU is executing one job, it is not stopped in between before completion. And preemptive SJF. In this method, while CPU is executing a job, if a new job arrives with a smaller burst time. Then the current job is preempted, sit back to the ready queue, and the new job is executed. It is also called the shortest remaining time first, SRTF. Shortest job. Some example of SJFA. Process processor. Four processes are given: P1, P2, P3, P4. Arrival time is also given 0.02, 0.0, 2.0, 4.0, 5.0, and burst time 7414. The Gantt chart representations is the P1. P1 is given for 0.0 is the arrival time and 7 is there. So the 0 to 7 is there, and after that the P3 is the 1 is added, the 7 plus 1 8. Then P2 is given for 8 plus 4 12, and after that P4, last is the P4. This is the, now you have to find out the shortest job there. So that's why we have taken here the P3. P3 is the shortest job. After the starting of executions, P1 is executions, and P1 is completion. After that the P3 is entering. The shortest jobs algorithms is finding the which process is taking the shortest time. So that's why the P3 is taking the only 1 seconds are there. So that's why the P3 is given for the next in after the executions of P1, and then P3 after that the 4 is the common time. So that's why the P2 and P4 are there. So average waiting times are there, the 0 plus 6 plus 3 plus 7, and these are the 4 processes are there. So that's why average waiting time is the 0 plus 6 plus 3 plus 7 divided by 4. 4 processes are given, that's why the 4 average waiting times the divided by 4 is equal to 4. Then so the P4 is given for the 0 to 3, P1 is 3 to 9, P3 is 9 to 6. This example is given for the another example. So P1. So the SJF can be either preemptive or non-preemptive. The choice arises when a new process arrives at the ready queue while a previous process is still executing. The SJF is a non-preemptive SJF and preemptive SJF. So this example is given for the preemptive example, preemptive algorithms, and the preemptive SJF at 0 time units there is only one jobs in the ready queue. Therefore, we must start with the J. At 1 times unit a new job is J arrives with a smaller burst time there. The JL will be the preemptive and JS will be the completes executions. At 2 times units is the J is arrives and the CPU starts executing it. And then now if we compare the balance burst times, and then the burst times of the JS both is the exactly same, applying the FCFS will continue at the end of the JS will be executed, and then balance of the JS. In this preemptive, the little explanations about the wait times and the turnaround times. In the above mentioned example, JS started its executions at a 0 units, but it was preempted. Its executions was over at 8 time units. Therefore, turnaround time for JS is 8 minus 0 is equal to 0. Then, for example, SJF is the preemptive. There are 4 processes are given for the execution, the P1, P2, P3, P4, and arrival times is also given for 0 and 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, and the 2.0, 4.0 and 5.0, and bus times also given there, the 7414. And then shortest job is the P1. P1 is the starting as there, so the 0 2. Then after that the P2. P2 is the 2 4. 2 4. Then after that the P3. P3 is the 5. And then again remaining part of the process P2 is consider the following processes P1, P2, P3, P4. Arrival times also given the 0, 1, 2, 3, and the burst time is given the 8, 4, 9, 5. These are the milliseconds. Gantt chart representation says P1. P1 is given for the 0 to 1. Then P2. P2 is the 4. The 1 plus 4 is the 5. Then P4 is given for the 5. 5 plus 5 is the 10. Then again again P1 is given for the execution, and so that's why the 1 is using, and after that the remaining 7 is adding to the P4, and the 10 plus 7 is equal to 17, and after that the remaining part is P3 is waiting for the execution. That's why the P3 is given time is the 9, so 17 plus 9 is equal to 26 are there. So process P1 is started at time 0 since it is the only process in the queue. The process P2 arrives at a time 1. The remaining time for the process P1, 7 milliseconds, is larger than the time required by the process P2. That's why we had the P1 is only for the 1 milliseconds, and after the executions of the P1, the P2 is given for the execution. And then the process P1 is the some questions regarding this topic. What is scheduling? First option A, allowing a job to use the processor. Second, making a proper use of processor. Third, all of mention. And fourth is the none of mention. Answer is option A, allowing a job to use the processor. Question number 2. What is FIFO? First in, first out algorithm. The first is first executes the job that came in last in the queue. Second, first executes the job that came in first in the queue. First executes the job that needs minimal processing. The third question is the orders are proceed in the sequence they arrive if dash 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 rule sequences the job. Option A, earliest due date. Option B, slack time remaining. Option C, first come first serve. And option D,